So 1A, 123 miles, 2 inches. So we did these in like the first part of this unit. This whole unit was just units and percentages. So so you might think back a little bit. We have been doing it kind of throughout the unit as well. So I start my beginning measurement, 123 miles, and I want to convert to inches. And I don't know how many inches there are in a mile, but I know there are 5,280 feet in a mile, and then I know there are 12 inches in each foot. So I'm going to do it that way. I'm going to go from miles to feet to inches. And that's kind of what I would expect to see. If for some reason you know how many inches there are in a mile, you can do it that way. But again, I just need to see the work. So anyway, so I'll do times miles in the bottom, and it's like I'm going to feet first, so feet in the top, and then there's 1 mile equals 5,280 feet. And then, as I said, I want to go from feet to inches, so feet in the bottom, inches in the top, and there's 12 inches in 1 foot.
There are
And
63,360 inches in 1 mile.
thank you. So you could do that too. In that case, you would just put inches in the top, miles in the bottom, and you'd put that 60,000 whatever number in the top, and then just 1 mile in the bottom. And of course, it's the same as just multiplying 12 times 5,280. And then note the units cancel, right? Miles cancel, feet cancel, and I just have inches, which is what I want. So you should always get these right. I mean, at least as far as the units go, because if the units don't cancel right, then you've made a mistake. If the units cancel right, then you've done it right. So I get 123 times 528 times 12, 0. Let's see. So 123 times 5280 times 12. Oh, it's huge. It's a big number of inches. So that's 7793280 inches. It's a lot. I mean, that's understandable, right? 123 miles is like going from, I don't know, Olean to Buffalo and back. So it's a good amount of inches. And this is an ugly number, and this didn't ask for this, but we could convert this to scientific notation too while we're here. Again, it didn't ask for this, so this would be your answer. But if you were bored, you could do this. You could do 1, 2, 3, 4, 5, 6. And so you could also write this as 7.79328. You can put the 0 if you want, times 10 to the 8. Oh no, what did I say? 1, 2, 3, 4, 5, 6, 6. Sorry. The 8 at the end threw me off. Right. So you can write like that too. It's a big number. You can write any number in scientific notation, but big numbers generally you write in scientific notation. Right. So questions with the first one? Cool. Let's try the next one. 546 grams to kilograms. Beep. 4. This one's not too bad. Grams to kilograms. So in general, it probably behooves you. Is that a word? I don't know. Behooves you to know that some of these abbreviations with the metric system. So know like milligram is 1,000th of a gram. Know that a kilogram is 1,000 grams. The other ones like centigram, centi means 100, so centigram is 100 grams. I don't know the one going the other way. Is it decagram? Is that 100th of a gram? I never used that one, but know at least a handful of the more common ones. Kilogram, gram, milligram are the ones you generally see, especially like for some reason there's always nurses and like, I don't know, people doing medical things, taking classes like this. So those kind of units in particular come in handy. Milliliters, cubic centimeters, things like that. Be familiar with the metric system is very good. Anyway, so all we need here though is that 1,000 grams equals 1 kilogram. That's all we need. So I'm just going to do 400. And then again, this is the work I want to see. 456 grams. And I need to see the unit analysis. So times grams in the bottom, kilograms in the top. Even if it's as kind of straightforward as this one. 1,000 grams because 1,000 grams equals 1 kilogram. And then the 1 goes with the kilogram. And so you just get 456 over 1,000 kilograms. And of course, as a decimal, that's just what, 0.546 kilogram. You could also do that in scientific notation, but it doesn't really do much. Um, yeah, so it's about half a kilogram, which makes sense because a kilogram is 1,000 grams and it's almost 500 grams. Any questions there? Okay. And the last one is potentially the trickiest. So this last one, top of the page, there we go. C, 42 pounds to milligrams. There. And I'm still really happy that we now know where the pounds abbreviation comes from. Libra poundo. So Libra was the unit, poundo is Latin for weight. The pound, our word pound, comes from the poundo. The LB comes from the Libra part. It's very exciting if you missed class that day. Anyway, so, and I tell you, 1 kilogram equals 2.2 pounds. So that's kind of the main thing we'll need. 1 kilogram equals 2.2 pounds. So what we're going to do, you can kind of try to concoct like a little strategy. What we're going to do is go from pounds to kilograms using this conversion. And then once we're in kilograms, we'll go from kilograms to grams to milligrams. Right? Right. So once we're in the metric system, it's kind of easy to go up and down it, but getting to the metric system is generally the hard part. So I'll do 42 pounds. Again, I need to see the work, so this is the work. Pounds on the bottom, kilograms on the top. And I would prefer to see it kind of in a natural way. Like you can probably find, if you Google how many milligrams in a pound, you can find that conversion rate, but don't do that. I mean, I'll give you credit, but it's not good because then you're just kind of, so make sure try to do it without using a reference. And then if you need to use a reference. Anyway, so pounds, 2.2 in the bottom, 1 in the top. And so now the pounds cancel, and I'm in kilograms. But I want to be in milligrams. And so the most natural way to get there is to go from kilograms to grams to milligrams. So I'm going to go to grams next. And as I said, there's 1,000 grams in 1 kilogram. So I put the kilograms at the bottom so they cancel. And I'm in grams. And then the last step is to get it into milligrams. And all the grams cancel. And you just need to know that there's 1,000 milligrams in 1 gram. It's 1,000th of a gram. So 1,000 milligrams in 1 gram. And that's going to be our answer. It's very large, right? So let's see, we get 42 over 2.2. So that's these first two. And then I have 1,000 times 1,000. And this is in milligrams. So you could plug that in your calculator. And of course you'll get an answer. But if you perhaps don't want to use your calculator, or for some reason, I don't know, are bored, you can kind of get it in scientific notation right away because 1,000 is 10 cubed, right? So this is something. Let me compute this part first. 42 divided by 2.2. So, I don't know, 19.1. So this is 19.1 times, and so 10 to the third and 10 to the third. What happens when I multiply powers of 10? What do I do to the exponents? Do I add or subtract or multiply? Anyone?
Add. Multiply.
You add them, right? So yeah. So when you multiply the power, so like this, if you think of 10 to the third is like that's the whole thing, right? If I'm multiplying those together, then you add the powers. And the reason that makes sense is that the power just means 10 times 10 times 10, right? So if I have 10 times 10 times 10 times 10 times 10 times 10, I get 10 to the 6 because I have 6 copies of 10 multiplied together. When the reason, what is the word? When you would multiply them is when you have a power of a power. So I'll do an example of that after we're done with this. But I have 19.1 times 10 to the 6 because 3 plus 3 is 6 milligrams. And, you could leave it like that. It's not in scientific notation. So if you're really being picky, you'd bring out a power of 10. So I'd have 1.91 times 10 to the 7 milligram. And again, if you really just wanted an answer, you could plug that in your calculator. So like I did 42 divided by 2.2 times 1,000 times 1,000. And you get that. You could just write that down. That's okay too. But where's the fun in doing things like that? Oh yeah, so this is an aside. So you would do multiplication when you have powers, when you have something like this. So if I had like, I don't know, 10 to the 5 cubed. So when you take a power of a power, then you multiply them. So it's 10, 5 times 3, which is 10 to the 15. And you can kind of prove that to yourself by counting how many tens you end up getting, right? So when exponentiation means whatever's between the parentheses, you multiply that many times. So this whole notation just means 10 to the 5, 10 to the 5 times 10 to the 5 times 10 to the 5. And so again, each of these now means 5 copies of 10 multiplied together. So I got 5 copies, 5 copies, 5 copies. Collectively, it's 15 copies, which is what you get, right? So just some exponential rules. It's always useful to know. If you take away anything from this course, hopefully your algebra improves a little bit. But anyway, all right, so that's number 1. Number 2, so you really need to understand number 1 to do number 2 and 3. If you don't know how to do 1, if you're having issues with number 1, then the next 2 are going to be worse for you. But I think from the homework I've seen, my math, everyone's just almost universally is doing well with the unit conversions. So I don't think we have too many problems, but if you need help, let me know. 2a, so 35 miles a day. And on here I have a day. 2 meters per second. Right. Oh, and I need one more unit that I didn't list here. I need meters to feet. Let me just do this quick. I should write it down. 1 meter to feet. All right, so let me write this down over here. 1 meter equals 3.28 feet. All right, so go away. All right, so and so first I'm going to write this. So I have 35 miles, right? And so it's miles per day. So the way you'd write this in like a book or something, miles per day. And remember, this word per means that whatever comes after it goes in the bottom of your fraction. So you'll have miles over days. And when there's no numbers for that, so it's just like 35 miles per day, then it's assumed that it's just 1 per single day, per 1 day. So when you write it, that's how you'll write it, as a fraction when you do your unit analysis. Now, I want it in meters per second. So I have 2 things happening, right? I need to convert the miles to meters, and I need to convert the days to seconds. Days to seconds is easier because we all know how many hours and minutes and seconds in a day, but we don't know how many meters are in a mile. So I'll start with the days, and then we'll do the miles next, all right? All right, so let's do this. So the way we convert the days to seconds is just, again, using the unit conversion we've been doing. So I want to make it seconds. So what I'm going to do, as I said, is I'm going to go from days to hours to minutes to seconds. And you can take shortcuts there if you like. Like, you know that there's 60 minutes in each hour, and each minute has 60 seconds. So each hour has 3,600 seconds, for instance. You can use that if you'd like. But maybe I'll do that. That doesn't matter. So I have days on the top. I'm going to hours. There's 24 hours in one day, hopefully. So 24 and then 1, and now the days cancel. And now I'm miles per hour, which is a pretty common unit. Next, I want to go to minutes. So I'll put hours in the top, and then put minutes in the bottom. And now the hours cancel. And what is there? There's 60 minutes in 1 hour. So I'll put the appropriate numbers where they go. And finally, to get to seconds, I put minutes in the top, seconds in the bottom. I put SEC on the sheet for seconds, but I think the actual abbreviation is S, but whatever you like. And then just like for hours and minutes, there's 60 seconds in 1 minute. Thanks to the Babylonians. I think it's the Babylonians is why we have everything base 6 with our time, or base 60. I don't know why. I mean, besides the fact that the Babylonians did it. And now we are in miles per second, which is not a common, not a common thing at all. All right, so questions so far? All right, so next, I'm going to convert the miles into meters, all right? And as I wrote down, so I wrote this down on my other sheet of paper here, maybe I'll put it up here. 1 meter equals 3.28 feet. All right, so that's what I'll use to go. And so what I'm going to do is I'm going to go from miles to feet to meters. Right. So as I said, some of this is kind of convoluted. Like there's definitely faster ways to get some places, but however you get there is acceptable. All right, and then I'm going to continue this down here. So I apologize, but all right. So now I want to go from miles to feet. So I'll put miles down here, feet up top. So the miles cancel. And then we just did this one, right? 5,280 feet in 1 mile. And then up here, I wrote that there's 3.28 feet in 1 meter. I almost said miles. And so I'll put feet down here to get rid of those and meters up there to keep that. And there's 1 meter in 3.28 meters, or 3.28 feet in 1 meter. And now, if you look through all of our units, we have meters, and on the bottom, we just have seconds, meters per second. And so if we put all this together, we'll have our answer. So let's see what we have. And so when they're long like this, all you do to figure out what the number is going to be is you just go along the top and see what numbers you have. So I have 35, the ones don't count, and then 5,280, 35 times 5,280. And then the bottom, I have 24, 60, 60, and then 3.28 meters per second. And then obviously you probably want this as a concise numerical answer. So that's where your calculator comes into play. There we go. So our handy dandy calculator, 35 times 5,280 divided. And I've talked about this before kind of at length. Make sure you put parentheses. Some calculators will take it fine, but some won't. 24 times 60 times 60 times 3.28. So 0.6, I don't know, 521, I don't know, meters per second. It's not very big, I will say. I mean, I guess it's really slow. Is it slow? I don't know. It's hard to say. We were going 35 miles per day, which is itself really slow. Like, so 35 miles divided by 24 hours, you're going, 1.5 miles per hour. So you're not going very fast if you're going 35 miles per day. Yeah, I don't know. So I don't know. You want to always make sure that the answer you get kind of will make sense with what you had, and I guess it kind of does. We're not going very fast, and this is meters. We're going like half a meter per second. There's like a kilometer is approximately a mile. So there's, yeah, I can believe it. All right, any questions with this one? Again, as I said, this one's more complicated. But all you're doing is you're doing 2 unit conversions at the same time. The first unit conversion's in the top, the second's in the bottom, and you just cancel them like you set it up and cancel the units like you would do normally, but it just depends where the unit is to where you put things. So like for instance, days are in the bottom, so I put days in the top to cancel them and get hours and so on and so forth. So there's another one of these. Let's do the next one. Letter B, 2B is the same kind of deal. So for 2B, we haven't done one like 2A before, but 2B we've done one just like. So it says 4.5 euros per liter to USD, United States dollars per gallon. So basically, this is how much your gas this is the units gas that you'd use in like England, or I don't know what England, actually no, like Europe, France. And then this is like what you'd buy gas with here in the United States. And we do need some more information. I need to tell you that 1 euro is about $1.18 USD, or just you can just put the dollar sign. And 1 liter is about 0.264 gallons. As I said, some things on the test you will need to look up, like that. Like if I didn't give you anything else on this test and I asked you to convert, I'm not going to ask and expect you to know these conversions. So you can look up like euros in a liter, or euros in a dollar, and stuff like that. And it's good to write down to the conversion that you're using, especially if it's euros and dollars. So when I go to check your work, depending what the day is, the amount of dollars in a euro will fluctuate. And so if you write down what it is when you're doing it, it could help me understand what you're doing. But I'll probably figure it out either way. Let's do it. So the same kind of setup. This is euros per liter. So again, per is the important word there. Euros per liter. So 4.5 euros per, all right? So the way you read that is 4.5 euros in the top per 1 liter in the bottom. So I'll write that 4.5 euro per 1 liter. And now our goal is just to convert the euros to dollars and the liters to gallons. And I already gave us direct conversions for these. So there's not going to be anything too tricky. It won't be as long as the previous one. So I'll do the euros first. So again, we set it up the same way. So euros I'll put in the bottom because I want those to cancel. USD I'll put in the top because I want that to be my unit. And then there's 1 euro in 1.8 or 1.18 USD. And then the liter, same kind of deal. I want the liter up top this time because I want that to cancel with that liter. And then I want to put gallons in the bottom. And then I just put the appropriate units where they go. So 1 liter, 0.264 gallons. And that should give us our answer. So in the end, I have USD over gallons, which is exactly what we want. So let's see. So 4.5, 1 point times 1.18. And that's all, because the one in the top doesn't matter because you're multiplying it. And then the bottom, I just get 0.264. And this is USD per gallon. I mean, you could also do like a dollar symbol per gallon. Right? And of course, we like a nice number. So what do we get? 4.5 times 1.18 divided by 0.264. Wow, is that right? It's huge. All right. So if my calculations are right, which I think they are, let me just double check. 1 euro, 1.18 USD, 1 liter. I guess that's right. All right. So I guess it's 20 bucks a gallon almost. It's $20.11 per gallon. Yeah, it's quite a large number. That's more than I anticipated. Right. So the thing is playing, so the euro and the dollar are basically the same, but what's kind of playing against us is that 1 liter is about a quarter of a gallon. So, or alternatively, there's 4 liters in 1 gallon. So if you're paying almost $5 for a liter and it's a quarter of a gallon, then you can kind of expect that in gallons, then you multiply this times 4 and you'll get how much it's going to cost essentially. So 4 times this is about 5, 4 times 5 is 20. It kind of works out, especially because the USD is not exactly the euro. So it seems high, but it seems to make sense in this problem. I don't think gas is actually that expensive in Europe. I know it's expensive, but it's not that expensive. Okay. Questions? Again, whenever you're doing problems in any kind of math capacity, or really any capacity at all, always try to just do it when you get an answer. Try to do a quick like sanity check. All right, we gotta go though. 3. 3 is another unit conversion one, but I think it's kind of fun. So an object's moving at 66 feet per second. How fast would you have to drive in a car to keep pace with the object? So it doesn't say as much, but unless you're in Canada, which I don't think any of us are, for better or for worse, you're driving in miles per hour. So basically, it just wants you to convert to miles per hour. All right, and this is kind of like, it's a little repetitive. It's kind of like 2A, but I figure it's good practice. I don't know what I'll put exactly in the test. Usually I don't put things so repetitive on the test, but it's okay. So 66 feet per second. We just need to convert the feet to miles, which is easily done, right? We can do feet to miles. There's 5,280 feet, what mile? So that's done. That's real quick. And then we need to convert the seconds to hours, miles per hour. And that is, we can go from seconds to minutes to hours. Or, like I said before, we can realize that there's 3,600 seconds in 1 hour. So I'll put seconds up here, hours down there. 1 hour is 3,600 seconds. Right. And the way you'd see that is that's just 60 times 60. There's 60 minutes in an hour, and then each second minute has 60 seconds. So you get 60 squared, which should be that. And then we're good. So everything cancels. And you're in miles per hour, right? And so what do we get? We get 66 times 3,600 over 5,280. And this is miles per hour. Let's see. It looks like it's going to be, I don't know, a little like 50. Let's see, 66 times 3,600 divided by 5,280. 45. It's exactly 45. Isn't that exciting? So we're going to go 45 miles per hour. And this problem is not very long, but this problem's kind of interesting, I think, because it's another example of a situation where you have a measurement in 1 unit, feet per second, and you convert it to an alternative unit, and it's instantly understandable. Like you have no idea what 66 feet per second is. I'm assuming no one does, but you convert to 45 miles per hour, and it's like, oh, that's the speed of the road outside my house. It makes, I don't know, it's kind of, it's like a lesson in learning to choose your units correctly in certain situations. Oh my God, green tea, amazing. I suggest the Wegmans brand green tea. It's so good. It's better than the Twinings. Twinings, it's much better. It's like in the green box. Go buy some. So that's 3. That's it for units, at least in this first part. 4 and onward kind of deal with percentages a bit more. So let's see. So 4. A baseball card is valued at $30. After a bit of time, the value dropped to $24. What is the absolute and relative change? So this should be a quick problem. It's asking you for definitions. It's asking you to see if you know absolute change and relative change. And we've covered them twice so far. We covered them when we did the exponentials in unit 1, and we're covering them again. So you should be good with them by now. But if not, it's all good. The initial value was $30. And where's my thing? There we go. And then it went down to 24. Oh, I'm so sorry. Go get COVID tested. I hope you're well. And then
I haven't left yet. I have to leave in like 15 minutes.
Okay. I hope it's not the nose one.
Oh, it is. I get tested every week. It's no big deal.
Oh, I'm sorry. Those sound bad.
No, my work does it. We only just have to go right inside the nose. It don't hurt at all.
Oh, okay. Well, that's good.
The lab we went through said that if we go all the way up, it will damage our nose tissue. So we only have to go right, like if you feel your nose, there's that bone. We just have to go right inside that bone.
Oh, okay. Yeah, that's like a reasonable amount. It doesn't like, I heard some people say it scratched like the back of their throat almost, like they could like feel it or something. And I'm like, oh, that's horrible. I'm glad yours is not. All right. 4. So it's initially valued at $30. After a bit of time, it drops to 24. So what initial and new value maybe? New value is 24. So the absolute change is literally just how much you get, how much difference there is. So you're going to do the new. So maybe I put absolute change equals the new value minus the old value. And you always want to do new minus old, even if it's negative. So here, for instance, it's 24 minus 30. So it's minus $6. We lost $6. It's not a good investment. I can't say that baseball cards are going to be probably ever good investments. They might be. I don't know. They're flammable. Don't invest in things that are flammable. And anyway, you lost $6. That's it. So that's what the negative denotes. Don't do this. If you do this and you get a negative, it should be fine as long as you're doing new minus old. So that's an absolute. And the relative is more of a nuanced sort of indication or indicator. So for the relative, you're going to do absolute change over initial value. So what the relative change studies, again, it just studies how much something is growing relative to the initial value, initial amount that it was. So, in this case here, I lost $6, but my initial value was $30. So minus 1/5. And as we talked about this before too, but when you're doing relative change, you usually want it as a percent. I didn't say what I wanted it as here on the sheet, on the test. So I would have accepted either. But if you want to make it into a percent, which makes it instantly more understandable, again, going back to the unit thing, kind of presenting our numbers in ways that make more sense to us. 1 divided by 5 is 0.2, and then times 100 is 20. So it's negative 20%. So the way you'd interpret this absolute change, or this relative change, is that my baseball card, which cost $30, lost 20% of its value. So my card lost 20%, oops, of its value. All right, so any questions with, what is that, 4? All right. And this stuff does come in handy, I will say. So I've been teaching at BOCES now, and that's all they do is like percentages and fractions. It's kind of, yeah. But, so these things do have applications in like trades and kind of practical jobs outside of mathness. So 5. I'll just put up. The population of Mali in 2009 was that number. The population of Burkina Faso at the same time was 21.11% more than Mali. What was the population of Burkina Faso? My girlfriend's brother actually was in the Peace Corps and was in this area of the world for like 2 years. It's crazy. I guess he lived like in a hut, like literally like off the grid. He was helping like villagers and stuff with malaria, I think. Very interesting. If that sounds like something you're interested in, check out the Peace Corps. Not this year. Anyway, so the population of Mali, population was 13 million and some change. All right, and Burkina Faso population was 21.11% more than Mali. So the important words here is more than. So we talked about this, I don't know, last week. And you can take some percentage off, like a discount, or you can apply some percentage on, like a tax or a markup or something. So here, we're essentially marking up the population of Mali by 21.11%, and that will give us the population of Burkina Faso. So the way we do that, so maybe I'll just note, so recall, oops, I can't write right now, recall. So more than, basically what you're gonna do is you're gonna do, I don't know what to call it, I'll call it P. And then 100% plus, I don't know, some rate, percent. All right, so this is my initial value. Right. And so this number will be R% more than P, right? So this is my initial value. And if I want something R% more than it, I just multiply it times that. For less than, so R% less than P, you just subtract. So it's gonna be P, again, my initial value, and then 100% minus R%. Right. So in this case, my population is 21.11% more than, so my population is going to be, so the population of Mali was 13 million and some change. And so I'm going to multiply it times 100% plus 21.11%. And now we just need to compute that. And so when you have percents and you're adding or subtracting them, you can just add them or subtract them. So when I add 100% and 21.11%, it's just 121.11%. So 13010,209 times 121.11%. Right? And remember, percent just means over 100. So to convert that into a decimal, I just take the percentage and divide it by 100. 1 to 1 by 100. So it's 1.2111. All right. So this is going to be 130.10209 times 1.2111. Seems like there's a lot of ones, but it's okay. All right. Any questions so far? And now you just multiply it. So let's see, move that like that. There we go. So times 130.10209. So it equals that big number. So 15,756,664. And I'll just round down. People. Because 0.12 is only a tenth of a person. It's like their toes. I'm not going to count it. There you go. I don't know if that's accurate, actually, but I think I did look up to writing this question. I think I Googled what the population of Mali was, and I think it was that. So the population is probably right, but I don't know about the population of Burkina Faso. But any questions though? So the important part is you understand some of this language, really. Like more than, you're adding the percent on, so you compute 100 plus that. Less than, you're subtracting. So again, you can think of like a markup or a sales tax for this one. And for less than, you can think of things like a discount. Like if you're at Kohl's and they give you a 40% off coupon or something, that's how you compute it. Awesome. So let's see, we did this one, we did that one. We're on 6. I like 6. Again, just more fun with percents. And we've done questions like this last week and the week before. So we bought a laptop for number 6. And it cost $1,302.85. The tax rate is 8.25%, which may not be the tax rate here. Someone told me it was 8%. I don't know. And so we want to know what the pre-tax cost of the laptop is. All right, so let me write this stuff down. So my cost, my after-tax cost equals $1,302.85. The tax rate is 8.25%. And I want to know the pre-tax. So need pre-tax cost. All right. So basically, it might seem more complicated than it is. Like it might not be clear what we have to do exactly, but all right, sounds good. Have fun. I hope it's not bad. I hope it's negative. That's the one where you don't have it. Yes, I hope it's negative. All right. So you just kind of set it up and kind of look and see what's happening. So basically, to get the whole equation, if I wanted to compute the tax, what I would do is I would take the pre-tax cost, I would multiply it, right? And its tax is a more than percent. So it's going to be 8.25% more than my pre-tax cost, like the sale cost of this laptop. So it's going to be 100% plus 8.25%. And then if I did that all out, that would give me my after-tax cost. All right. So this is kind of one of these problems where you plug in what you know and solve for what you don't. So I know my pre-tax cost. Well, I don't know my pre-tax. I know my after-tax cost is $1,300. So I can plug that in. So pre-tax cost. And then this I can figure out, right? So that's 108.25%. As a decimal, which is what's more useful for me, I can do that by dividing my percent by 100. So it's just 1.0825. So this is 1.0825. And that is equal to my after-tax, which is the 1,300 that I was given. 1,302.85. All right. So if I want to do this one, if I want to find that number, all I need to do is divide by both sides by this 1.0825. Right? So my pre-tax cost equals 1302.85 over 1.0825. Right, and then that would be my answer. So let's see what happens. So I have 1302.85 divided by 1.0825. So it looks like it's about $1,203.56 maybe. Okay, you round. So whenever you have dollars, you just round to the nearest cent, unless you're like, I don't know, like a gas company or something. Right. There you go. So just if there's ever any confusion on whether you don't know if you should, like, because one of the things that you might do for this problem is you might say, oh, I'm trying to remove my tax, right? I'm trying to find out what my pre-tax cost was. So what I'm going to do is, again, you might think to yourself, I might do 8.25% less than this number, right? But the problem with that is that, and we've talked about this too, but the problem with that is that the 8.25% has some number that it's like taking that percent from, right? So so like for this, in this case, for the tax, the 8.25% is referencing the pre-tax cost, not the after-tax cost. So if I remove 8.25% of my after-tax cost, I'm going to actually remove more money than I pay taxes on, if that makes sense, because 8.25% of this number, the after-tax cost, is more than 8.25% of the pre-tax cost. So that's why that doesn't work. If you try to remove it that way, you're going to take off more than you initially had. So the only way really to get the pre-tax cost is to divide by this 1.0825 number. All right. So that's a little confusing, but any questions? If there's ever any doubt, just set it up all nice. Like write down what you do to compute the tax, and then just solve what you don't know. And you shouldn't get lost if you set it up like that. All right, 7 is just a bunch of scientific notation ones. So, oh, and order of magnitude. So for 7a, I have 200. All right, so this one's a short one. So again, so this is an integer, right? There's no decimals, nothing like that. So my decimal point, even though it's not shown, is at the end. And what I need to do is I need to move it to the left until I get just one number left. So 2 places, right? So 2 to the left. When you go to the left, that means you have a positive power of 10. So this is going to be 2.00 times 10 to the 2. And again, this is another kind of situation where I would hope that there's not any confusion whether it's positive or negative, just because if it's positive, then your number is going to be bigger than 1. If it's negative, it's going to be kind of teeny, like it's going to be 0.00 something or another. So it's positive, so I know my number is kind of a bigger number, right? Which 200 is. All right, let's try another. Oh, and the order of magnitude is 2. 2 equals 2. It's always just the power in the exponential. It's whatever that is, right? Even if it's negative, it's just the negative number. B, a million. Oh, that one's a dumb one. It's okay. We did a bunch of these back last week, so even though this one's a little silly. Same really thing as 200. My decimal point isn't represented, but when it's not, it's always at the end. And you just move it until you get one number left in front or behind, depending which way you're going. So here we're going 1, 2, 3, 4, 5, 6. So 6 to the left. Again, when you go left, we're positive powers of 10. So it's just going to be 1. And you don't need to put the zeros. That's really the point of scientific notation. So I'll just put 1 times 10 to the 6. And so the order of magnitude is equal to 6. Again, it's just the same as that number. Okay. And there's just one more, C. This one's a little more difficult. So point, let's see, 1, 2, 3, 4, 5, 6. 6 zeros. 1, 2, 3, 4, 5, 6. And then 4, 2, 3, 2. All right, so here, as I said, this and the first 2 went to the left. Here, we're gonna go to the right. So again, I'll do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, Oh wait, no, I want to stop there. Sorry. I went too far. So 1, 2, 3, 4, 5, 6, 7. So I'm going to stop after my first digit. So this gives me 4.232 times 10, and we're going to the right. So right 7. So 7 to the right. And so it's times 10 to the minus 7. And so the reason you stop at the 4, by the way, is just because, remember the scientific notation, you want it to be put down here. You want it to be with the form, what did I use? I think I used E times 10 to the B, where this is between 0 and 10. And this is any some integer. All right? So that's the form we wanted. So here we stop at the 4 after the 4 because then that gives us an E that's 4.232, which is between 0 and 10. If we went one further, we'd have 42, which is greater than 10. So it doesn't really fit this standard form. And that's really it. It's just a format. So there's no like special reason we stop there versus the 2. It's just the way it's done. And really the idea is you're just pulling out as many powers of 10 that you can. Like you imagine there's like a hungry power of 10 monster and your number, and he just keeps pulling out powers of 10 until there's none left and eating them all. And that's this guy here. So there's no powers of 10 left, so that's why he stops, because it's less than 10. It's really good. All right. Any questions? Oh, and the order of magnitude is -7. Okay. So again, you just take the whole exponent, negative or positive. Okay. I think there's just a couple left. Yep, 2 on the back. So, and this is stuff we've done more recently. This is stuff we just did. So, convert the following into units, which are more insightful. Again, insightful here, we talked about this in the earlier problem actually. It just means more understandable, that are better units for what you're measuring. So you should always measure things that are, or you should always put measurements in units that are natural. So I have 10 to the 5th centimeters. That's not very natural. I don't know how long that is. But if we convert it into miles or, kilometers, that'd be better. And then this one here, I have 10 to the -4 miles. Again, no idea what that is, but if we convert it into inches, it might make more sense. So let's try it. Let's do 8a. So 8a, I have 3.45 times 10 to the 5 centimeters. And there's no right or wrong unit to convert it to. Really, you want to just convert it to a unit where it's going to be a more concise number. So you want to convert it into something that's like, so this is centimeters, and we have a ton of them. So I want to convert it into a unit that will have less things in. So like miles or kilometers. We'll convert it into kilometers, I think. But I guess we could also do, maybe we'll do miles. It doesn't matter. Maybe we'll do miles. We don't use kilometers too much. All right, so here's what we'll do. So I have, and I'll loose leave like that. So 3.45 times 10 to the 5 centimeters. Let me get it into meters first. So centimeters, meters, there's what, 100 centimeters in 1 meter? Centi, meaning 100. And so the centimeters go away. And we have meters. And then I'll use the same conversion that I used earlier. So 1 meter equals 3.28 feet. So meters and feet. So 1 meter equals 3.28 feet. And then I'll go into miles. So feet into miles. 1 mile is 5,280 feet. So let's see what happens. And you'll note now, meters cancel. This is miles. I'm sorry. The feet cancel. The meters cancel. And now I'm just in miles, contrary to the hash mark through it. And let's see. So let's see what we get. So in the top, I have 3.45 times 10 to the 5th. All right. So times 3.28. All right. Divided by 100. And then divided by 5,280. Look at that. So it's about 2.14. 2.14 miles. So that's kind of the purpose of this, right? Like we talked about, it's just over 2 miles, but in terms of centimeters, it's 3.45 times 10 to the 5 centimeters. So you're just kind of like unraveling it and kind of making it make more sense. And the other one is just the opposite. So this one, we want to go to a bigger unit. For the other one, we want to go to a smaller unit. So the other one is B. So it's 4 times 10 to the minus 4 miles. And what you can do is, if you're not sure, you can go to like feet first. And if it's still quite tiny, we can go to inches. So let's try it. So 4 times 10 to the minus 4 miles. So let's go to feet. Maybe let's go to inches. I think feet might be too tiny still. Miles. The miles cancel. 1 feet is 5,280 miles. Or 1 mile is 5,280 feet. And we'll just do inches and see what happens. If it's too big, we'll go back. So my feet cancel. I want it in inches. 12 inches in 1 foot. Okay. And now my units will be in inches, but let's see what they actually turn out to be. So again, I'll do 4 times 10 to the minus 4. And be careful with negative exponents too. Sometimes some calculators are funny. If you have one of these scientific ones, you might want to do it differently. I'll show you in a sec. All right, let's see what that is. All right, that's the E we talked about. And then times 5,280 times 12. And there's nothing in the bottom, right? But you'll see it's just 25.3, well, I guess it's not, it's equal, 25.344 inches. So it's just over 2 feet. So, you know, this is another example where this is a crazy, it's not, no idea how big that is, but then you convert to inches or feet and it's totally fine. It's 25 inches, or in feet, it's 2.112 feet. Both of those are good. So either, if you converted to either of those, that would be acceptable. Yeah. Oh yeah, and so on this calculator quick, because we have just enough time, I think, to finish this last question. On this one, just be careful. So you can do like exponent, and then I think I'll put parentheses. So 4 minus 4. Yeah, so it still kind of works. And it gives you actually the decimal expansion. So just be careful. You know, if I was doing this one, I would probably put that in first, and then multiply it times 4, and then times the rest. So times 5,280 times 12, right? And you get the same answer. It's kind of hard to see with my overhead, but it still works out. Anyway, last one, just before we run out of time. So this one it's a scale model one. So it's just like the solar system one we did with the bike path. And we did another one too, I forget what it was. But it's just like that. So it's just a unit conversion one, but it's kind of worded in a funky way. So let's try it. So you have a model airplane that consists of a perfect scale model of a 747, like a Boeing 747. Every inch on the model corresponds to 20 feet on the real 747. So that's your conversion. That's your rate, like the way to go back and forth. If the model has a wingspan of 10.6 inches, how big is the wingspan of the 747? So let me write down. So we know that 1 inch on the model, maybe I'm gonna try that again. 1 inch on model equals 20 feet on real 747. That's the conversion. So for A, it says if the wingspan of the model is 10.6 inches, how big is the wingspan of the real 747? And so all we have to do is, it's 10.6 inches, so on model. And so we just convert it in the same way. I want inches on model on the bottom, and feet on real 747 on top, right? And so the inches on model cancel, and my units will be in feet on 747. And then I have 1 inch equals 20 feet. Right? So it's just 10.6 times 20. 10.6 times 20. So it's, oops, you can't see that. 212. Right? So it's 212 feet. So So the wingspan of a real Boeing 747 is 212 feet. And for B, same kind of idea, but we're going the opposite way. So for B, it says if the 747 has a length of 250 feet, what is the length on the model? So now we're going from real life feet to inches on the model. So 250 feet on real 747. But I'm going to set it up the same way I set up the previous one. So I'm going to put feet on 747 in the bottom, and then inches on model in the top. And then you just put the corresponding number, right? So 1 inch on the model corresponds to 20 feet on the 747. And so now this feet on the 747 cancel. You can think of them as units. And I just have 250 over 20 inches on model. So let's see what we got. So 240 over 20. And again, it's kind of dark over there. 12 and a half inches. So 12.5 inches on model. So it's kind of cool, actually. And this kind of technique works whenever you see like model anything that is to a scale. Like you'll see a lot like model trains. If you've ever gone to a model train store, that's the same kind of idea. You know, they have different scales. And the idea there is if you take the dimensions of that model train, whatever its scale is, if it's like, you know, 1 inch equals 10 feet or something, and you blow it all up in that same way, you'll get exactly the dimensions on the real train. And if, depending on the model, you might get the exact dimensions on even like little components on the model train. Everything should theoretically be scaled down. But yeah, it's just unit conversion essentially. The only thing that's kind of interesting that's funny maybe is that like you're converting feet to inches, but they're not the same as just regular feet and inches. This is feet on a real plane. This is inches on a model. So you might be tempted to convert feet to inches in a normal way, but you have to just be careful to use the given conversion. All right. It's just like the bike path. We had kilometers in space and kilometers in the bike path. They're both kilometers, but they're strictly speaking, they're just different units at that point when you're scaling things, right? Because some are on a bike path, some are in space. We're just scaling. Yeah. So, any questions about any of these problems on the practice? We all good?
Yeah, I do.
Yeah.
On 8A, why did well you had 1 meter over 100 centimeters times 3.28 feet over 1 meter times 1 mile over 5 to 80 feet.
Yeah.
But why didn't you like go across like 3.45 times 3.28 over 100 times 5280?
Did I not do that?
Well, you divided by 100, then you divided by 5280, and I got a complete different number, and I was so confused.
I might have made a typo. Let me see. I think you might be right. I might have forgot to multiply. So I'll do 3.45 times 3.28. But maybe let's do that. 3.45 times 10 to the 5th. So that's that. And then times 3.28. So I get that. And then divided by 100. And then divided by 5,280. So we'll do 100 times 5,280. Same thing.
Oh, okay. I definitely didn't do the first part where you're supposed to convert it into a like number.
Oh, yeah.
The 3.45 times 10.5.
Oh, did you just do 110? It should be 10 to the 5th.
Yeah, I just wrote that out and then divided by 100 times 5280.
Oh.
That's why I got a weird number.
Okay. Sounds good. Yeah, as long as you know where you got the mistake, yeah. But
all right, thank you.
Yeah. Any other questions? Cool. All right. So again, I'll post the homework. I forgot to post the percentage homework. I'll post the percentage homework. I'll post the practice test. Practice test, I'll give you like a week maybe. The homework, you'll have a long time too. So no, don't stress about it. And yeah, any questions, let me know. But I'll see you Thursday. All right.